All right, welcome back to winter term, everybody. This is fluid mechanics. It is a fully online class, and you'll get these lectures on Tuesdays and Thursdays is what I am aiming for. If I don't get the lecture up on Tuesday or Thursday, like you go to look for it and it's not there, then that means I'm behind. When I do put it up, I will send you a link. Like I will send you an alert, okay? So you don't have to just keep checking. If it's not up by a reasonable time on Tuesday and Thursday, it's probably not coming up. I have a lot of classes, so it's gonna be tough to keep up with. I'm gonna use Blackboard to track everything. The lectures will come to you as recorded lectures like this one. The homeworks will come to you in Blackboard, so the calendar is gonna be very instrumental. This is the lecture that I'm doing right now, Tuesday the 9th. This is your homework for Tuesday the 9th. That typically is due by the next time we meet, which is Thursday. So Tuesday to Thursday is a quick turnaround, but then this one wouldn't be due until like the 14th or 15th. I think I put the 14th on that one. So they're going to be out of the book, and this is the book, right? It's an okay book. I don't love it. I don't hate it. It's lacking in some areas, but it's good in that we get to do both hydraulics and hydrology. So hydraulics is about using fluids to transmit power or to create power. Hydrology is essentially water behavior. So like stormwater, rainwater runoff, those kind of calculations. So we'll do both. The first one, very mechanical engineering. The second one, very civil engineering. So you get a little bit of both in there. All right. Maybe I'll flip the camera around and we'll get some of this in here too. Let's finish with the Blackboard though. The syllabus is in week 1, day 1. That's today. Oh, make a liar out of me. There's no syllabus listed. I did a syllabus, but maybe I didn't put the link in the right spot. Let's see if I put it in Tuesday. Nope. All right. Don't know that I can solve this problem. I can try and solve this problem right now. Let's see if it exists. No, it's not going to be there. Sorry, this is not part of the lecture, but that's how it works. Okay, this is an old syllabus. So the new syllabus is probably on my laptop. I will have to load it. I'll try to do that by Tuesday, which is when you're probably listening to this. So there you go. All right, so let's go back to the homepage. Lectures will come to you on the day that they're created. So this one is in Tuesday. There'll be another one on Thursday. I'll keep them pretty short. They'll just be very topical and very associated with your homework. Like your homework tonight is really area and volume type of calculations. So I'm going to talk about that just a little bit, and then that's going to be the end of this lecture. So you will submit homework in the homework submission area. So I need that in PDF form. So it'd be nice, you know, if you had something like Cam Scanner to snap a picture of your homework and put it in. Homework format, let's keep that pretty clean. It'd be nice to have it on engineering computation paper. And similar to what you did in statics, if you have that class, or strength of materials. So don't get it too tight, right? And just be clear with problem statements. Why is this upside down? Maybe it's because of this. No, it's not that. Whoa, that's super weird. Why is it doing that? It's like inverting. You see that? Or they don't know why it's doing that. Okay, I'm gonna kill this screen capture. Oh, I think it's because the video's on. Interesting. Just not sure about that. Let's do this. Oh, no, it won't do it. Okay. I'm gonna stop the share. And it is definitely upside down, so let's not do that. We can turn the off and see if this works. All right, much better. All right, so homework format, let's get your name at the top. We all do this the same, it's gonna be much better. So it would be Donaldson. It would be ET222. Date would be great. 1/9/24. And then number of pages would be nice. So like, you know, 1 of 2 pages, something like that. Anything like that is good. Okay. So that's the start of it. And then let's see if I can focus. That's better. And then just list the problems. So like if it's chapter 1, number 2, something like that, or you could just write 1.2. I would figure that out as chapter 1, number 2. However you want to do it, but give me kind of the name of it. Give me a problem statement like find the area. So you don't have to write it word for word out of the book. You can just this is funny. You can just reason I don't think it's sharing the screen, so I'm going to share the screen. Sorry. All right, now it is. You can just abbreviate the problem statement, so it doesn't need to be word for word out of the book. Just give me the gist of it. It would be great to have a graphic, so, and make your graphic kind of nice, right? So I'm going to actually use a circle template to create my pipe, and I'm going to say that this thing is 4 feet in diameter, right? So here's the graphic that I'm going to use. This is kind of given information. You want to list all the given information. So diameter equals 4 feet. And any other piece of information that is, you know, available in the problem, you want to make sure to capture it. And then you want to go for the solution. You can actually write solution if you want. Or I'll just know, right, that after the graphic and the given, this would be like the given. So you can title those if you want, up to you. Either way, I can figure it out. But this is a standard kind of engineering documentation format. So I want to try and get us to use it, right? So the solution, I would like the formula. So if you're using area equals pi d squared over 4, I would like that formula before it's filled in, right? If you're using area equals pi r squared, then give me that formula, right? Whatever formula you're using, I'd like it first, and then I would like it filled in. So I'm going to use this first one, area equals pi 4.00 feet. We're going to make that assumption that all numbers coming to us in the book are accurate to hundreds, 0.00. So that gives us some kind of accuracy. The book does talk about accuracy in this significant figures conversation, and it does a pretty good job down here. I don't like the whole sig fig conversation, so we're not going to follow that. That's very mathematical, not very engineerish. This is very engineerish. So this basically is saying that you can only be as accurate as the least number of significant figures in any quantity in the computation. So if we don't know the accuracy of a number, right? We have to be as accurate as that number. Like, you can only be as accurate as the least accurate number. So we are going to make an assumption on all numbers are equal to this hundredths. So given 4 feet in the problem, I then assume 4.00 feet, right? Because that'll give me a solution that is at least accurate to 2 places. And that's what we want. All right. If your data is given to you more accurate than that, then reflect that extra accuracy for sure. Okay. All right. Over 4 n squared. So there's the formula I'm using. There it is filled in, and then I can go straight to solution. So crunch it a couple times, folks, and make sure you're getting good numbers. So I'm going to go ahead and run this. I'll use pi. So with a HP, you enter numbers, and then I'll go 4 and square it, and then I multiply these top 2, and then I divide by 4. So that's how an HP works. 12.56637.061. But since I'm only accurate to 2 places, I can only reflect 2 places in my solution. Okay. If I was going to use this area further down in the problem, I would use this, the whole thing. I'd store it. Okay. But this gives me 12.57 with rounding. 12.57. And what's my unit? Feet squared. Got to have units on any solution. I need units in the formula also. Very important. This becomes my answer. So I commit to it with a double underline and an arrow. That's how I do it. You can decide however you want, but please somehow identify your solution. If I made an assumption, I would want to note that assumption. So normally that would go above the solution. And maybe you wouldn't have to do this because we are all going to just assume these 2 decimal places. But you know, maybe that could be my assumption. I assume accuracy of 2 decimal places, right? But if you make an assumption, note it. So I know that you've made that assumption. That would be very helpful. Okay. So that's a homework format. That's a problem. You can easily get a couple problems on a piece of paper. Don't try to get 10 on one piece of paper, right? Keep it nice and spread out. This is easy for me to grade. And also, you know, I can write some comments in here. Right? I can actually print them and make some comments. So if you get it too tight, I can't make any comments or questions or notes or anything. So don't make it too tight, please. All right. That's the homework format. I think you all are aware of it. If you're not, let's keep it like this. Definitely need a problem statement. I definitely want a graphic. If I don't have those 2, I'll probably toss it back to you. Okay. All right. Fluid mechanics is one of the core courses that you're going to have. Statics, strength of materials, fluid mechanics. Those are big courses. The first chapter really just talks about significant figures and accuracy, which we just talked about. And also, it does a little bit of engineering design, which I think is interesting that fluid mechanics is doing that. But it goes through a little design loop here. Pretty interesting. You should look over it. It talks about environmental issues, which is a big deal in the hydrology world of storm rainwater runoff. Okay, so that's why they're having this conversation. But really, this first chapter is just setting up the whole rest of the term. So, the other thing I want to pull in is we will work in both metric and US. So you'll get problems in both, and we need to get comfortable with it. So this is a little example problem of a conversion, right? I think they're first going to convert to meters, and then they're going to go and do something else, right? Find the circumference. So one of the problems with the book is it doesn't have great conversions. So sometimes you got to look conversions up online, believe it or not. Their unit conversions in the back are pretty weak. like it's this little bit. And then kind of this little bit over here. So not very impressive, right? But there is a little bit back here. So you might want to tab that page. That's what I do so I can get to it quickly. But just use the internet too if you need to convert something from the metric system to the SI system. All right. And then these are your problems at the end of the chapter. So each chapter is going to have problems. We won't do a lot in this first chapter. I think you're doing 1 and 4. They're pretty simple. So good luck with those. On Thursday, why it's not auto focusing? I'll have to work on that. On Thursday, I will do another lecture and we will start into chapter 2. So you might want to do some reading because we do get into some very fundamental concepts. So we're going to do solid, liquid, and gas because a fluid can be, I don't want to say solid, but it can be a liquid, which has form, or it can be a gas, which doesn't have. Both of those are fluids that we use. We use air for a lot of things. We use water, and then we can use other gases and other fluids like oils, right? So we're going to talk about the properties of all these things. We're going to talk about the specific weight versus the specific gravity of various liquids, and then we'll calculate the viscosity of fluids. So that's chapter 2. These are kind of the properties of different fluids. So we're going to learn a lot about those properties. So it's a good chapter to kind of just read through and digest a little bit. It has some decent, simple example problems. But it does set up the term with some fluid mechanic terms, you know, and some variable setup. So where this maybe have been a different variable in a different class, you know, it's shear stress here. So that was also shear stress in strength materials. But here are some new ones, right? Density is rho, mass is m, volume is v. So if nothing else, it's good just to look through these, right? And then in the chapter, there's some tables that we'll use that you just should note, like specific weight of water at different temperatures. So there we go. All right. Good luck with your first little homework assignment. Welcome to winter term. Welcome to Fluid Mechanics Online. And I'll keep these kind of short and we'll do our best to grind our way through. I'm going to try to set up kind of an open lab time where I'm just going to be in 1659 that fits into your schedules. So if you need to come see me about a homework set or content or anything, you can come find me. So I will get the syllabus up. I feel bad about that. Sorry about that. And that's it. Have a great evening. Talk to you on Thursday.